My name is Henry. I'm with the engineering dean's team. I'll be kind of hosting things a little bit today. But this presentation is not about me. It's about Dewey here, who's the director of the Ware Lab, and then everyone else who's involved with the different design teams here. So we'll be starting off with an introduction from Dewey. We'll be watching a video about the Ware Lab, like a bit of a tour. Then we'll have a Q&A opportunity with different representatives of various design teams that work out of the Ware Lab here on campus.
Yes, my name is Dewey Spangler. I'm the manager here at the Ware Lab for the College of Engineering for Virginia Tech, and I want to welcome our participants who are thinking about. I believe that it's a mixed group of folks tonight. That we have people who are thinking about engineering and wanting to join the College of Engineering, or you've already made that decision and you haven't decided on a major or what direction to head into, and looking and exploring what the Ware Lab has to offer gives you a great idea on what major that you might be interested in pursuing. And it's an important choice. And my choice as an engineer back in the 1980s was to go into civil engineering because I love tall buildings. I wanted to design tall structures, and that's the thing that really got me excited. So I went into structures. So as you make that decision as to what you want to do, don't do it for any other reason than it makes you excited. And we've got a lot of very excited students at the Ware Lab. They do great projects. We're going to talk a little bit about those. We have a really good panel of folks tonight some of these folks have been with the Ware Lab several years. So they're going to be able to answer any questions that you have about what we do here. So to give you just an overview, the Ware Lab started in 1998, and Joe Ware was our founder. Joe Ware was a 1937 alumni of Virginia Tech, and he was in the program of mechanical and aeronautical engineering. So back in those days, they didn't separate aeronautical and mechanical, and they didn't have aerospace because there was no aerospace program in those days. There was no space. There was aero, but not space. So Joe went on to get his bachelor's degree at Virginia Tech and then went on to Caltech to get a master's degree. He did it in 1 year. So Joe was a very smart fellow. And then he went to work with Kelly Johnson, who was the flight engineer or the lead engineer designer for the Skunk Works, which was a division of Lockheed Martin. Skunk Works was set up to develop top secret aircraft for the military and for the CIA. And Joe worked on a lot of those different versions of aircraft. So if I mention the word U2, maybe a lot of you may think of the rock band U2, or maybe not. U2 is actually a spy plane that was developed in the 1950s. That was a high altitude airplane, very high tech for the time. Joe was part of that. He also helped develop the SR-71, which is the fastest airplane even today. I think achieving Mach 3 or 3.5, or maybe even more. And probably some things we'll never know about. Joe was actually visited Area 51 and was part of the development of Area 51. So there's some things that we'll never know about what Joe did probably. But what he wanted to do was to say, okay, Virginia Tech gave me my start as an engineer, and he wanted to return back to Virginia Tech something. And him and his wife Jenna came up with the idea of developing a facility that has not just mechanical engineering students or just aerospace engineering students, but also civil engineering, ocean, industrial, business majors as well, physics, computer science people. So this lab has a lot of energy, and it's about 10,000 square feet. It's not the biggest facility on campus, but it probably is one of the busiest. And so here Joe is during the opening day. And again, if you want to do something with your career that involves hand-on component of engineering, a hand-on component, in other words, if you want to study theory in the classroom and then take that theory in real time and go to a lab and put it to use almost that day or something, sometimes in some cases that day, a Ware Lab is a facility for you. Now, it's a lot of hard work here. The folks work long hours. A lot of this is a lot of these teams are what we call volunteer teams. They receive no academic credit. The mechanical engineering teams that I'll talk about, we have some representatives for those teams here in just a minute. They receive, a portion of their students receive credit. So there's senior design credit available in Baja, Formula, Bolt electric motorcycle, and hybrid electric vehicle team. So if you're interested in doing senior design credit at the Ware Lab, that's a team one of the teams you'd want to steer towards. The picture here is a person working on the Bolt motorcycle. And talk a little bit about leadership. I've introduced myself, and Phil Ratcliffe is our assistant manager. He is the shop supervisor. So we have a full-time shop machinist. He has over 20 years experience in that field. And if he can't answer the question, probably no one can about machining, welding, or anything that you're trying to do as far as constructing your project. Dr. Watford, this is a little bit out of date. Dr. Watford used to be our director. She's moved on to another role with the university. We have Keith Thompson, who is now our director. So I certainly need to update that slide. But we're a very lean operation. We're servicing over 200 students, 250 students. There's really 2 full-time people here and a director who oversees the operations of the Ware Lab and many other things. So our machine shop, the Collagus machine shop, Collagus is the person who donated a lot of the equipment. And you'll see a person here working on a vertical mill, and then a person here working on a lathe. So what we design as engineering students is built and tested here at the Ware Lab. So not only are you getting involved with the number crunching behind doing something, you're getting involved in the building of that something and the testing of that something. And then eventually you go on to competition. So we have 3 lathes, 3 milling machines, a bandsaw, and various other pieces of equipment that you have access to. Welding, we have full TIG and MIG welding. Steel Bridge team does MIG welding. The Formula Baja teams use TIG welding. So we have a plasma cutter and a sandblaster. So we have something almost a fully comprehensive weld and machine shop facility that allows you to do pretty much everything you need to do. So the CAD facilities, you'll study CAD in the freshman year as a new student at Virginia Tech. And we have you put that to use. And we do that in the design phase, which is usually in the fall semester. So you'll do a heavy amount of design and conceptualization in the fall semester. A lot of that involves CAD. You're learning CAD, you're applying CAD at the same time. And then the picture here on the left is someone troubleshooting something on the computer screen. In my day, we had drawing boards, pencils, and paper, and those days are long gone. Now we do everything on CAD. You don't even take drawing classes anymore like you did in engineering school 20 years ago. On the right-hand side, these folks are actually designing a part that they're going to machine on the lathe. So they use their CAD by developing 3-dimensional models that can be transferred over to CNC controlled equipment within the machine shop. So that's the cycle that occurs actually in industry. So we're giving you industry experience while we're charging you tuition. We're not paying you yet to do this level of work. One day you'll make the big bucks doing it, but right now you get to learn what's actually done in industry.
Hi everyone, and welcome to the Ware Lab, one of Virginia Tech's premier undergraduate engineering design labs. The Ware Lab is home to multiple student design teams where students can get valuable hands-on experience across multiple disciplines in engineering. Today we're going to take a tour of the Ware Lab as well as check out some of the facilities and also talk to some of the students that call the Ware Lab home and are in here day in and day out.
One of the first things that you'll see when you walk into the Ware Lab is our machine shop, where students from almost all the design teams go to manufacture parts for their projects. The machines included in the machine shop are multiple mills, lathes, a CNC router, and many other tools. And the hands-on experience gained there is very beneficial to the students. Now we're going to take you into the lab and so you can see up close some work in action.
So this is the weld shop in the Ware Lab. A lot of the teams utilize different resources in here. Most of the welding we do is TIG welding. We can also do oxyacetylene and MIG welding. A number of the teams use that to weld parts for their various projects. We also have a plasma cutter and a couple other grinders, sandblaster and things like that. And it's a great way to kind of learn how to weld and learn new skills in here.
Hey, so this is VT Baja. I'm Kevin Lambert. I am currently the transfer case design lead, which is kind of funny because I'm the only one designing it. But so Baja SAE is an international design competition. We build, design, and race a small single-person off-road vehicle. So we are an international competition. It's an SAE competition as Society of Automotive Engineers, for those who don't know. We compete with teams all over the world: India, Puerto Rico, Brazil, China. They come to competitions. We don't get to go to any overseas competitions usually, but we have 3 a year in the US on the East Coast. 2 often actually happen on the West Coast. It's a good time. California, Arizona. Those are always fun to go to.
Hi, my name is Matt Watterson. I'm a senior in mechanical engineering and I'm a member of the FormulaSAE team here at Virginia Tech. What we do is we design, build, test, and then compete with 2 vehicles each year. So we make an electric vehicle and a combustion vehicle. What you see behind me right here is our new electric vehicle that we're working on right now. We also have parts of our combustion vehicle in the background, but that one's still being manufactured. What we do is we compete in a competition in Michigan and California each year, where it has 2 parts. There's dynamic events where we're physically driving our cars, testing their capabilities, and then static events where we're presenting things like our design, business scenarios. We have representation from all majors across the College of Engineering, as well as some other majors from the business college. And one of the really cool things about what we do is we design and manufacture about 80% of the components on our vehicles. So for example, here I have an aluminum upright for our combustion vehicle. This was manufactured by one of the students on our team using a 5-axis CNC mill. And then here I have a carbon fiber steering wheel that we made. And this was completely made and designed by our team members.
Hey guys, my name is Shreya Chandramoli and this is Designable Fly. So we make remote controlled aircraft for an annual competition, and we switch rules every single year. So it goes between military style and commercial style. So what you can see here is a military style plane where we deploy a sensor that has to light up mid-air. As well, we have to carry as many shipping containers as possible. So it really constrains our plane to what it is capable of and what it has to do. Around the room, you can see all the other planes from the past years. We have a really small plane that looks like it can't fly, but flies pretty impressively, which got 2nd place. And we compete against about 115 teams. So it's really nice to see that VT does an amazing job each year.
Hi, my name is Megan Bieber. I am a senior in civil engineering and a co-captain of the Concrete Canoe design team. So at Concrete Canoe, we design, construct, and race a canoe entirely made of lightweight concrete, as you can see behind me. Now, what we typically do is in the fall, we design, and that consists of our mixture design and our hull design for the canoe. And then in the spring, we're typically focused more on construction and actually placing the concrete into the form and letting that cure. One of my favorite things about this team is that we do something called paddle practice, where we go to Crater Lake and actually take one of our past canoes and race it to prepare for competition. At the end of the year, we go to the ASCE Virginia section regional competition, and this is where we race our canoe and present to the judges. We hope to see you soon.
Hi, I'm Blaise Cornett. I'm the current president of the Sailbot Team. So our objective is to design, build, and test an autonomous sailboat for competition on a yearly basis. Right here is kind of some of the current and past projects we've worked on. These are the rudders from our boat last year, kind of using 3D printing and molds with plastic to make those, and then a majority of our work is composites, and then this here is our mold for this year's boat, which we're in the process of kind of getting ready to do the composite work for that and hopefully end up with something like this.
Hi everybody, my name's Gavin Harlow and I'm a member of the Steel Bridge team at Virginia Tech. As the name probably gave away, the point of this design team is to build a bridge made out of steel. At competition, the goal is to span a 6-foot river and hold a weight of 2,500 pounds. All the steel here is ordered and constructed on site with a variety of welding, machine shop, plasma cutting, and a variety of other skills that we use.
Hey guys, my name is Will Haneke and I'm a member of the hybrid electric vehicle team here at Virginia Tech, where our main goal is to convert a Chevy Blazer from a normal combustion engine into a hybrid electric vehicle. So we integrate a high voltage battery as well as a integrated traction motor that provides electrical torque to the rear wheels. So we're a 4-year design competition here at Virginia Tech, obviously housed inside the Ware Lab, with our main goals to be reduce energy consumption of the vehicle, as well as increase consumer appeal and integrate connected and automated vehicle systems to automate some of the functions of the car. Some of our sponsors are GM, MathWorks, as well as the U.S. Department of Energy, which is really important in our mission. Obviously, we get a Chevy Blazer, like I said, and we're able to do a lot of amazing things with it, especially since we have the great tools in the Ware Lab.
Hi, my name is Audrey Corral, and I'm the president of the Human-Powered Submarine Team.
Hi, my name is James Duval. I'm the treasurer of the Human-Powered Submarine Team. And as you may have just heard, we are the Human-Powered Submarine Team here at Virginia Tech. We are an engineering student design team based in the Ware Lab, and our main focus is to design, test, and build a fully flooded human-powered submarine that we take to race in our biennial competition at the Naval Surface Warfare Center in Carter Rock, Maryland, where we race in a drag-style event. So basically, we're worried about making sure our sub is able to go as fast as possible. So that we, in the track that they have laid out there in the data tiller tow tank.
Our team is comprised of 35 members, and we represent all grade levels and all kinds of different engineering majors offered at Virginia Tech.
As you can see here, between the two of us, we have our submarine that we brought to our last competition, Trident. It's a little bit cut up right now, but we've been using it as a test bed for some of the materials and subsystems that are being put into our newest submarine called Nautilus. That one's still in the works. Fortunately, our competition this year was moved to virtual format, but we're still working to complete it before the end of the year.
Hello everyone, my name is Will Gessner, and I'm a member of Bolt VT, which is a design team in the Ware Lab where we take a stock motorcycle and convert it to being fully electric. Now our goal as we are designing an electric motorcycle is not to shoot for cutting down greenhouse gas emissions and things like that. It's to build an electric motorcycle that can compete with and outperform gas racing motorcycles. So we're really looking for high performance racing. Here we have Bolt 4, which is the bike that was designed and built in our previous design cycles. Our design cycles are 2 years, so the first year is mostly a lot of CAD and testing on a small scale, and then the second year will be really building the bike to what you see here. Now Bolt 4, which is here, is pretty bare bones right now. We have our motor in here, but that's really about it. That's because we are preparing to rebuild Bolt 4 this coming weekend for our race in 2 weeks. We also just started our design process for Bolt 5, which will actually be the first Bolt bike where we are building our own frame. So that's something cool that we're getting into this design cycle.
So I think, Henry, what I'd like to do is just introduce the Steel Bridge team, and then I'll ask Chris Pageant to maybe say a few words about Steel Bridge.
So Steel Bridge team is a lot of fun. We're a pretty small group, but essentially what we do is we create a 1/10 scale model, so about a 20-foot steel bridge that has to be self-contained and constructed during competition. So each piece can only be around 3.5 feet long. So the issue isn't making a strong steel bridge, it's making a strong steel bridge that can be constructed in about a 30-minute window and is strong enough to hold 2,500 pounds. So we build the bridge all ourselves. We weld it, we cut it, we construct it on site, and then we tear it down. And we're we're scored for competition based on deflection, how much it falls during loading, and aesthetics.
Thanks, Chris. Very good. Then Concrete Canoe, we have a representative for Concrete Canoe.
Hi, I'm Kathy Bruckner, and I'm here from Concrete Canoe. So I'm a junior, and I've been in Concrete Canoe since I was a freshman. So what we do on Concrete Canoe is mostly what it sounds like. We design a canoe model and make it using concrete. But what's different about what we do, usually when you're thinking about concrete, you're thinking about like normal structural concrete, which is very heavy compared to what we use, because it's made with like cement and like gravel and sand as aggregate. But what we use instead is we use lighter materials like expanded glass beads. Here's a piece here. You can kind of see the little glass beads in it, and also it has little bits of an expanded shale in it. So it's all very, very small, very lightweight aggregates. And so in the fall semester, we're coming up with different combinations of aggregates and cement and water to test. And in the spring semester, once we've decided on a mix, we actually go through, we CNC the form out of foam and then mix our concrete and put it in. And in normal semesters, we're able to take it to competition and get to actually row our canoe. But yeah, so that's Concrete Canoe.
Kathy, thank you so much. And those are the two civil engineering teams, also construction engineering, architecture. Those folks are very interested in those projects. I don't believe we have a representative for Astrobotics. If I'm wrong, please let me know.
It's me, Dewey. It's Grant Anderson.
Oh, hi. Okay.
Sorry about that. Yeah, I'm the team lead at Astrobotics. We design and build a autonomous mining robot designed to mine the surface of the moon to try and get to the water underneath. Shown are a couple of our previous robot designs. We use mechanical, electrical, and computer science engineering primarily to kind of design and build our robot. We compete at the Kennedy Space Center every year. Not this year, just due to the current everything going on. But we usually compete. It's a good time. We're primarily made up of MEs, mechanical engineers, electrical engineers, and computer scientists. We generally have a little bit more of a spread going on now. We have a lot of computers this year.
So when you say you have a lot of computers, you mean you have a lot of computer science majors?
Computer engineer majors.
Okay, gotcha. Okay.
Yeah. So we're a pretty broad team. A lot is applied. We mostly designed for like mining the surface of the moon, try and get to the ice underneath, because for long-term projects such as Artemis or other long-term missions, having access to water is really useful for the astronauts. So that way they have access to water for fuel and obviously to drink and other such purposes.
Grant, okay, thank you. That's a great point. And as we move on to the next team, Baja, I will say that if you find water on the moon, you find water on Mars, it makes future space missions much more feasible. So what they're doing on the Astrobotics team is helping NASA to really make these future space missions feasible on a cost basis. Okay, so we have the Baja SAE team.
Thanks, Dewey. I'm Kevin Lambert. I am a senior on the Baja SAE design team here at Virginia Tech. So what we do as Baja is, fortunately, you have a bunch of pictures of the buggies there, but we also have two of our current ones hanging out back here. We design, build, and race these in international competitions against teams from all over the world. So really cool thing, along with a lot of these Ware Lab teams, these are engineering, the full engineering process, start to finish. You get to experience that. Virginia Tech has a senior design program you do as seniors, but as a Ware Lab team and as a Baja member, you can come in as a freshman and have multiple years learning these design projects and actually get to build, design and build really cool. So, such as this is the shell of one of our gearboxes, and this is one of the gears we have made out of a super alloy called Ferrium C61 that allows us to make these gears very small, very lightweight, and yet consistently hold for, I think those have been through almost 5 competitions now. A lot of teams' gears make it through a competition and a half. So these are the kind of things we get into on Baja and actually get to do the hands-on work like Dewey talked about. We're machining these in the machine shop. We're welding the chassis together in the weld shop. It is a blast. And once you get it all together, going to competition, it's an amazing time. And you learn, honestly, far more than you would ever learn just attending classes at Virginia Tech. Not to say that the classes are bad. The classes are great. This is even greater.
All right, Kevin, thank you so much. And the picture shows here, I think you guys can see this, the evolution of the vehicle from 2012 to 2017. Baja has been with the lab for many years, and even before the lab existed. And if you look at these vehicles from this distance, it doesn't look like there's any difference in the vehicles. But the key to the innovation for teams like Baja is the component design. So this year, for the first time, they are going to a 4-wheel drive vehicle, and Kevin's showing that right now. For many years, they've gone to a back-wheel drive vehicle only. Now they have to go to a 4-wheel drive. So that more than doubles the complexity of what they're trying to do. So this is a thing that the Ware Lab engineers have to confront. It's a challenge, and they're always good at meeting that challenge. So I'm going to go to the Bolt team, and I will ask the Bolt representative to chime in.
Hi, my name is Murray Ray, and I am the senior team lead of the Bolt team. Our goal here on Bolt is to take a gas-powered motorcycle and then convert it to electric and take it racing. The goal of the team is specifically to beat gas-powered motorcycles on the track with an electric powertrain. Currently, we have just finished up our 4th generation of our motorcycle, which was based off a Yamaha R1M. And Yamaha is now a sponsor of the team because of that bike. And we have just began design of our 5th generation bike, which has a fully custom frame. So it's not based on any current motorcycle, but our own. The team competes in the ARMA electric motorcycle racing division, and we compete against other colleges around a racetrack, New Jersey Motorsport Park. Our bike goes up in excess of 200 miles per hour and is powered by lithium-ion batteries.
Murray, thank you very much. And did you have another representative today that you want to say a few words?
Yeah, Wilhelm.
Yeah, my name is Will. I'm the powertrain lead for this year. My sub-team is focused on the development of the battery pack and whole power system that allows our bike to go such high speeds. This year for senior design, we focused on the drivetrain portion of Bolt 5. And so we designed a fully custom gearbox to fit our motor and our team specifications. And we're gonna test it in about a couple weeks from now. So very excited about that.
All right, Will, thank you very much. For the sake of time, we'll move on to the next team, Designable Fly.
Yeah, so we are Designable Fly. We are a engineering design team open to all majors. We're comprised of give or take 80 people, and they mostly from aerospace, we also have mechanical, ISE, CS, you name it.
Yeah, so I'm the chief engineer, and so we design, build, and fly remote-controlled aircraft for an annual competition. And the rules change significantly every year, so our planes look very different. You can see the 2 planes right here look quite different, and then you can see the one right behind us, which is quite giant and also very different. So we switch between military and commercial aircraft every year. So we're on our military year, and we are tasked to deploy a sensor that has lights on it and should flash midair, and then also retrieve it. So it simulates a military aircraft that does sensing missions. And we compete against about 100 teams internationally. And so we'll switch between going from Tucson, Arizona to Wichita, Kansas. And we do pretty well every year. The best that we scored is second place, and this year, hopefully, first.
All right. Shreya, thank you very much. And I want to mention something about this team that you usually beat Emory and Riddle. Is that right? Emory and Riddle is probably the number one, or close to the number one aeronautical school in the country, and Virginia Tech schools them now and then. I understand, so that's always good to hear. But you guys are a great team. Let's move on to FormulaSAE, and you'll see this image shows a lot of evolution over the team's many years. So I'll ask that representative to talk about that team.
Hi guys, I'm Ben. I am the head of recruitment for FormulaSAE. Our team, we design race cars each year to take to competition. Open wheel, formula style race cars, so like Formula One or IndyCar. Currently we're designing two vehicles, an electric vehicle and a combustion vehicle. Both have their different complexities from powertrain. The biggest difference is powertrain complexity on the electric vehicle compared to the combustion vehicle. And they're in totally different stages of development. Everything there is a combustion vehicle, which has been around, as you can see, since 1990. It's been before 1994. We won competition in 1990 or something like that, and been around for a very long time. We have a large number of members from various different disciplines. I'm an electrical engineer, but we've also got a bunch of it's mostly mechanical engineers, aerospace engineers, a solid mix from everything to get the whole vehicle on the ground. We take them to two competitions, one for the combustion car in Michigan, and the other one is in California, now Nevada, for the EV car.
Okay, well, let's hear from the Human Powered Submarine team.
Hello, everyone. My name is Jillian Hirsch, and I'm the Vice President of the Human Powered Submarine team, and I'm joined tonight by my friend James Duvall, who's the treasurer. But our design team is tasked with building a human-powered submarine. So we basically build a fully submersible underwater vehicle that is pedaled similarly to a bicycle, and we take it to international competitions and we race them. So it's a pretty fun experience. We have a lot of different types of engineers on our team. We have aerospace, we've got mechanical, we used to have a mining engineer, we have a material science engineer, a lot of electrical engineers. So we have a lot of ocean engineers as well, very, very geared towards the ocean engineers. So it's a really fun competition. It's definitely an interesting thing that we get to build, but everybody on the team has a really good time with it.
Thank you so much. Let's move on to hybrid electric vehicle team. Do we have a representative for that tonight?
Yep. Thanks, Dewey.
Okay. Thank you, Will.
Yep. So for the hybrid electric vehicle team, it's pretty self-explanatory based on the title of our team. But we are actually a 4-year design competition where we are turning an internal combustion engine vehicle into a hybrid electric vehicle. So this year, and our 4-year design cycle for this competition, which is titled the EcoCar Mobility Challenge, we are converting a Chevy Blazer that started initially with a V6 engine in it into a hybrid electric vehicle. So we took the V6 out, we put a 4-cylinder engine in it, and then we're also integrating a integrated traction motor for the rear wheels and a high voltage battery pack. So we're kind of going all out. This is pretty much all student run. Like I said, being a 4-year design competition, we have a ton of time to work with the car. And in each design cycle over that kind of 4 years, we have different goals for the competition. So this past year was integrating all of the mechanical components. And going into our 4th year, next year, we're going to be working on connected and automated vehicle systems, which means we're going to automate some of the functions of the car, such as lane changing, as well as adaptive cruise control. So that's all going to be controlled by computer algorithms and some really cool software that we're implementing.
And one of the things that we like to say about HEVT is that we're definitely in it to decrease energy consumption, but we also want to increase safety of the car as well as increase consumer appeal. So as cool as the cars are, we want to keep them safe and make sure that they're definitely doing better in terms of energy consumption.
Will, very good. Thank you. And if you notice the slide, I think everyone can see this. In 17, they had a Camaro. This year, they're this design cycle, they're using a Chevy Blazer. So they have to change their emphasis every 4 years. And GM just doesn't give them the same car every year to redo. Part of engineering involves being knocked out of your comfort zone. So you think you've got everything figured out, you're ready to move on and do greater and greater things, and then you have to kind of take a step back when new challenges present themselves. So thank you very much. And we'll move on to Aero Design. Actually is no longer a team at the Ware Lab. I don't think they're still active, but if anyone is interested in that particular team, let me know and I can find some information for you.
We have a couple more questions here in the chat, actually.
Oh yeah, absolutely.
I think you might be able to answer these. The first one is, about what % of first, second, and third year students get involved with these teams? And also, is it difficult to get onto a team?
Well, to answer the first question, we probably have about, believe it or not, about 20% of the population here who complete the survey are freshmen. Now, out of that, probably maybe 10% are actually working in the lab, and sophomore, it's a little more. Junior and senior are going to be really the biggest percentage of students that work in the lab. As far as getting on the team, the way that works is if you are very interested, let's say you're interested in Baja, and you really want to be a part of the Baja team, and you're in the College of Engineering, you're a freshman or maybe a sophomore, what I recommend you do is you send me an email, and I will send you a team leadership contact. And those folks will let you know when the next meeting is going to occur. You go to the meeting, which I guess this year will be, and maybe even in the fall will be Zoom based. It may go back to live meetings, but regardless, you go to that meeting and you talk to people and you get a feel for the team, and then make your decision. And as far as how many people they accept, they do have to go through an interview process. Many of the teams at the Ware Lab conduct interviews, face-to-face interviews. I guess now would be Zoom interviews, very similar to job interviews, just to know or get the idea that you're really serious and you want to be a part of this, because there's a lot of resources that go into this. I hope that answers the question.
I think it does, yeah. And just from my personal experience with a lot of my friends back when I was a freshman, if you're passionate about being on a team, you can definitely find a place. So it's not like it's an exclusive club just for juniors and seniors or anything like that.
Well, our next team will be Sailbot. And we have a representative for that team. They'd like to chime in.
Hey, I'm Blaze Cornett. I'm a senior in ocean engineering working with the Sailbot team. The Sailbot team basically designs and builds an autonomous sailboat for competition, usually on a yearly basis, but due to COVID, that's kind of been fluctuating a bit. Fall semesters usually spec for design, and a lot of that design work is done in the ASD, which is the aerospace design facility in the Randolph. And then the spring semester is designated for construction, and a lot of that is composite work. So this year, we're kind of experimenting with new construction methods in terms of how we produce the mold and kind of the composite construction procedure.
I'm sorry, Blaze. Your team has to do full autonomy. You can't do partial autonomy. Is that correct?
So we do include kind of a remote control function in case the autonomous capabilities don't work as intended, but the goal is for it to be fully autonomous.
Now the picture shows a flexible sail. You guys have gone to a new design as a solid sail. Is that correct?
Yeah, we switched to more of a rigid sail because it's easier to manufacture and it's easier for our aerospace guys to kind of design and test.
Okay. All right. Blaze, thank you very much. All right. We'll move on.
We actually have another question here. Does the university cover the travel expenses for competitions? And I feel like if we ask every design team here, we might get different answers, but if anyone wants to chime in about their funding situation.
Why don't we, maybe I can pick someone, or does anybody really want to discuss that? Funding is important. I tell you what, how about Jillian, how about you? Can you talk about your funding?
I would actually like to pass that question to James. He's our treasurer, so he's very much in charge of all of those good things.
Yeah, I guess just to confirm, the question was about competition funding, correct?
Yeah, and if the university covers it, or what other sources you have funding.
So I know for our competition, at least, I can't necessarily speak for everyone else. We pay like out of one of our many accounts, the entrance fee for the competition. But the funding that we get funding from the university, so we can use university funding towards that. We have several accounts that aren't affiliated with the university that we could also use if we so desire. We also have another account. I'm sure every team's like this, but each team has multiple accounts probably. I know for us at least we have 4, 2 associated with the university, 2 not. And a lot of our funding actually comes from outside sources, so companies that either donate financially or they give us services that they discount or stuff like that. And I guess that we technically count that as a donation as well. So, but for competition specifically, yes, we can use university funds for that.
And I'll add quickly that the teams generate probably 80% across the teams. 80% of this is generated by corporate sponsorship and by sources outside of Virginia Tech or outside of the Ware Lab. I give the team, I don't, but Ware Lab gives the teams $500 a year. And James, how much are you going to spend on the human-powered sub this year? Do you know that figure off the top of your head?
This year we've probably gone about 8,000, and that's usually normal for us.
Right.
So
and it goes up from there. So Formula Team might spend over $100,000 to develop 2 vehicles, and HEVT may do about $100,000 a year just to get ready for competition. So a lot of fundraising is involved. I'll end out by saying that thanks to the panelists. You guys did a great job tonight. I know you guys are studying and getting ready for midterms and projects and presentations and trying to get the competition, and you take some time out to speak to the young folks that are coming in. So I think it means a great deal to these folks to learn more about what you're doing. And we do a lot of outreach. I will mention that. So one of the cool things about, in addition to all the other things that's going on, Ware Lab students, as you can tell, learn how to articulate well. All the students tonight were very articulate and discussed their projects with passion. In the engineering professions, that's very important. You have to sell what you're designing. You have to sell what you're producing. So Ware Lab gives you an opportunity to practice that. Very important for the real world. And again, this is our corporate sponsorship. You can see there's a lot of companies there to help us out. And then there's some private sponsorship that they help as well. So our location is right across from Kelly Hall. So please, right now we're limited on visitors, but once the COVID-19 restrictions relax, we can start having visitors come back to Virginia Tech. Right now we're essential personnel only, unfortunately.
All right, yeah. So thank you for all the panelists who came out tonight. For everyone, all of our attendees, I hope you all were able to learn something tonight. Maybe hear about a design team that you didn't know about beforehand. All right, yeah. Just one last thank you to everyone who was able to come out and talk today, everyone who was able to listen. Hope you all have a great evening and a great rest of the week.